Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
And we're here through the magic of time shifting all the way back in October 23rd.
Recording shows at the end of October for the end of November. That's how this works.
That's right. So it's a month old. In internet years, that's like 9.
But we're on the road all of November.
It's true.
But we'll be picking a bunch of cool shows while we're traveling that we'll publish in December.
And we promise this is good, timely stuff. Aaron Stannard's here with us. We're going to be chatting with him just a few minutes. But first, we have this little thing called Better Know a Framework. Roll the music.
Awesome. Hey, man, what do you got?
So I didn't know this, but Airbnb has published a really comprehensive JavaScript style guide.
Interesting.
On GitHub.
Is that really something that Airbnb should be doing?
So some major technologies were developed by Airbnb, weren't they?
Not that I know of.
Yeah.
But, it's all these tech companies, they build stuff. So it's interesting that they share it too.
Yeah. So this is like one of the most comprehensive style guides I've ever seen. It's a bazillion languages, a bazillion companies use it. That's an actual number.
Nice.
There it is. So check it out. I mean, I don't know if everybody is really interested in another JavaScript style guide, but this one's got everything.
That's nice.
Yeah.
Well, and all we know for sure about a JavaScript style guide is yes, you should have one.
You should have one, right?
Yeah. Make your code intentional.
Yep.
I'm a believer.
And I saw her face. All right. Well, that's what I got. What do you got?
Grabbed a comment off of show 1338, which we did with Mr. Stannard back in August of 2016, talking about Akkad.NET 1.1.
Yes.
Just a little while ago, a couple of years back. And this comment comes from Matthias Weiser, who said, Aaron mentioned Aaron for networking. Aaron is based on the Disruptor library, which is also available in .NET. And Disruptor outperforms blocking collection by multitudes as well. This is an open source project called Aaron that is specifically about high performance networking.
Okay.
And you may also want to check out recent stuff from Matt Warren, who has so many great ideas. And you're right, because I've been trying to schedule Matt to do a show for a while. We still haven't actually got it locked down. But yeah, there's a lot of interesting stuff going on in the high performance area of .NET these days. And certainly Akka plays into that. Aaron plays into that. Lots of cool thinking around core. So great to be digging back into all of that. So Matthias, thank you so much for your comment. A copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .NETRocks.com or on Facebook. We publish every show there twice a week. And if you comment there and we read it on the show, we'll send you a copy of Music to Code By.
Absolutely. And follow us on Twitter. I'm at Carl Franklin. He's at Rich Campbell. Send us a tweet. We'll give you 5 stars. I promise. Promise. Okay, let's bring back Aaron Stannard. Aaron's the founder and CEO of Petabridge and the co-founder and maintainer of Akkad.NET, the open source project. Prior to Petabridge, Aaron founded Marked Up Analytics, a real-time in-app marketing and analytics service used by 1,000+ developers. Prior to that, he worked at Microsoft as a startup developer evangelist. Welcome back, Aaron.
Thanks for having me.
What have you been up to these days?
Oh, everything. We've been doing a lot of work on the Akkad.NET side, actually trying to go and build up some enterprise-level tooling. It's kind of interesting, the arc the project's taken, really, since we spoke last. There's been a lot of companies that have been adopting it at very large scales. We're talking clusters that have, like hundreds of nodes worth of Akkad.NET servers running inside of it. And so one of the problems you start to run into when your networks get that large is monitoring and managing them starts to become a bit of a problem. So a lot of my time has been spent over the past really year and a half working on trying to build some better DevOps tools and training resources. So we launched a couple of sort of new tools around that. Last year, we built a command line tool that allows you to do things like just figure out if there's a node that's unavailable inside your network, and you can kick that node out or force it to restart or something else. That was a free command line tool called Petabridge.command that we released last summer. And then this summer in August, we released a proprietary tool called Phobos, which is a sort of turnkey monitoring and tracing solution for big Akkad.NET clusters. So if one actor in one node in a 100-node network receives a message from a web API, and it needs to go and communicate with, let's say, 50 other nodes inside the cluster, we can trace every single individual message being passed all the way up and down the chain and visualize it using a third-party monitoring or tracing tool like Application Insights or Zipkin or Jaeger.
Yeah.
These are all the sort of different sort of vendor solutions for that sort of thing. So I've been personally spending a lot of time sort of working on that type of tooling, even though that's kind of like adjacent to the Akkad.net project itself.
Yeah.
On Akkad.net, we always have the sort of routine things that we're working on, improving performance, trying to take advantage of some of the newest tools in .NET Core. There's been a lot of really exciting developments, particularly as part of .NET Core 2.1. So, there's always work being done on it. And it's a really exciting time to be a .NET developer right now, I think, with the direction the whole platform's moving in.
Yeah, it's hard to argue with that.
I'm really glad that you guys are kicking butt with Akkad.net. It's been a long time since we talked about any actor model systems on .NET Rocks. And yeah, I think every time that you came on, we would have to rehash what that is just because we feel like it's just not a lot of people are hip to it. But so I'm not going to do that now. Go back and listen to those early shows or go to getakkad.net if you want to check that out. But I'm curious to see what the status of Orleans might be in the wake of the success of Akkad.net and where they differentiate themselves.
Sure. Well, Orleans seems to be doing well. We have a friendly relationship with them. I see Sergey Bykov, the founder of the Orleans project, often when I'm at conferences and that sort of thing. And he's one of the nicest people in the .NET community overall. He's a great guy. The other members of their team are pretty accessible, like Ruben Bond and a couple of others on Twitter. What they're working on, I think these days mostly, in terms of just my sort of visibility into the project, they're doing a lot of work around designing systems that are strongly consistent. So things like distributed transactions is something that they've been working on implementing. And I think they have versions of that available in Orleans 2.0.
Oh, good.
Wow.
I don't remember if it's stable or not yet, but I think it is. So they've been doing a lot of work on that. And I know they've been trying to work on, I know they had a lot of work to do with getting their code generator, since that's one big difference between Orleans and Akkad.net is in order to go ahead and compile your Orleans solution, there's a bit of code gen that has to happen before you ship your application. That's just kind of part of how Orleans kind of weaves its magic into the solution there. And I know they had a bit of work to do getting that to work with .NET Core. I believe that's all done now. I think that's been done for like a year. And, it looks like the project's doing well. And I'm genuinely grateful that there's multiple choices out there for .NET developers to try to build distributed systems.
Right.
Even though obviously I have a bias, I lean very heavily towards Akkad.net and its philosophies, which are different from Orleans. And I'll touch on those in a second.
Sure.
But I really dislike the idea of there being, I'm putting this in finger quotes, one true way of doing something.
Yeah.
Sure. Yeah. We debunk that all the time because it's such foolishness. If there was one right way, we'd all be doing it.
Yeah, exactly. It'd be self-evident, right?
Yeah.
And so I really strongly push against that. So Orleans has a different philosophy on how to build these types of systems. And I think for certain software development organizations and for certain software developers, that'll probably be the better option of the two. So, I'm glad it's out there because I think choice is essential to having a healthy ecosystem.
Right.
As long as it's actor models.
So I'd say choice with any types of frameworks, right? Mm-hmm. So different web frameworks, different frameworks for doing logging, different frameworks for doing the actor model. I think, I don't really believe in one size fits all solutions.
Sure.
Categorically. So yeah.
So not everything should be built with actor models.
Definitely not. No.
So you think Ready Player One, that whole virtual world was built with Akkad.net?
I'd say theoretically you could. A lot of the original use cases for the actor model were all multiplayer games.
Yeah.
Right.
So Blizzard, for instance, uses Akkad.net in some of their applications. So the guys behind, World of Warcraft and Diablo and all that. I don't know exactly what parts of their system are built using it, but I had some developers from there tell me about it.
That's cool.
So yeah, theoretically, yes, it could be used. But we also know, video games have been built using the Orleans style actor model too. I think the original use case was all of Halo 4's like achievement system and presence system was all built on top of like the very first rough cuts of Orleans back in the day. And Dragon Age 2, another big sort of a multiplayer video game, was built on top of a port of, it's called Orbit, I think is the name of that project. It's a Java port of Orleans virtual actor model, essentially. So in terms of what the biggest differences between the philosophies are of something like Akkad.net and Orleans, Akkad.net is a set of tools that are essentially developers have the ability to choose which parts of Akkad.net they want to use and which ones they don't. And you can use Akkad.net in something as simple as a Xamarin application running on someone's iPhone.
Oh, really?
Yeah, and we do. We do have a lot of developers who do that. We have some developers who are trying to get Akkad.net to work nicely on the latest versions of Unity. Although there's still a couple of challenges there, since I think Unity depends on ahead of time compilation, which doesn't play nicely with some of the reflection that certain parts of Akkad.net use. But nonetheless, we're working on that. So it can scale down to work in really small environments like that. We also have people running Akkad.net on like embedded devices. So these are small, lightweight devices that are running Linux and .NET Core. So Akkad.net can work in really small contexts like that, or it can run in really large clusters.
IoT? Yeah.
Or other applications where Akkad.net tends to get used a lot. Finance is a big category. It's probably, in terms of Petabridge, our company, since we commercially support Akkad.net, I'd say the vast majority of our customers are in IoT, finance, and logistics. So like transportation networks that use Akkad.net for figuring out the real-time location of cargo or vehicles, that sort of thing.
See, and most of these scenarios, when I hear them described, seem like server-side, lots of sources of data being fed simultaneously, executing as actors, interacting as necessary, and giving you a composite view. So can you walk me through now I want to actually run this on my phone because it does something great there?
Sure. So the actor model was originally created to go ahead and solve concurrency problems, right?
Right.
And that's sort of the use case of running actors on your phone is really about that. It's where, let's say, I've built a Xamarin Forms application, and I have lots of events that occur off-site, so maybe on a server somewhere, that I need to display in real time to an end user. So like a really simple example might be a chat application.
Sure.
Where I'm connected via, like, let's say, a little TCP socket to my server, and I need to go ahead and bubble up notifications from multiple chats that are maybe occurring simultaneously inside my app. Well, what the actors can do is help manage the visual display state for all of that content as it's coming in.
Nice.
So basically, the actors can kind of handle a lot of the dispatching between the network layer and the presentation layer in a manner that's really simple for the developer.
Nice. Yeah, no, I totally get that then. That mindset of there's units of work that need to be sorted and organized in the right places into a UI. And so it's just all of it's independent and asynchronous.
Yeah, exactly. So each one of those actors that might be managing its own unit of work, they can all operate concurrently at the same time.
Yeah.
Yeah.
And also situations where latency is of utmost importance. You mentioned stocks, chat. Chat not so much, but games, obviously, location of cargo, that kind of thing. I would even say like an Uber or a Lyft.
We've had customers in Europe that have built sort of like one-off taxi dispatching and management solutions for like their specific region that are totally built on top of Akkad.net. And yeah, what you're pointing to is that the server-side environment, like the sort of the big server-side clusters, all tend to have a real-time component to them. So in the case of some of our customers in finance, things they might be doing might include real-time risk analysis on trades if they're doing real-time trading. So they have to go ahead and run a predictive algorithm to figure out how much exposure is executing this trade going to create for my bank or for my portfolio management company. And then other examples of real-time sort of behavior that might occur in a server-side environment like that might be responding to actual commands you have to go and execute. So for instance, if I'm an insurer and I get a request from a customer to generate a premium based on whatever piece of data they go and send, one of the things that might affect my close rate, how quickly I'm able to go and onboard these customers and actually sell the insurance policy, is going to be based on how quickly I can turn around an accurate quote.
Right.
And if you're a really big insurer, you might be doing tens of thousands of these continuously at any given time. So there's a lot of competition in markets for trying to be the fastest player in the space.
Right.
And a tool like the actor model gives you a lot more manual control over how that's organized and try to make it possible for your organization to achieve those benefits and win in that market without having to hire a bunch of PhDs. Yeah. So
nothing against PhDs.
Nothing against PhDs. No.
There's just not enough of them around.
Yeah, exactly. They're a scarce resource, and it takes a very long time to produce them, right? So a tool like Akkad.net gives people who are, career-long .NET developers the ability to build systems that can do these things in a manner that's easy to understand. And one of the most important things for me is how easy is it to teach a new person how your system works? And I think the actor model, if you follow some of the design principles that we usually train our users on, is very intuitive once you've gotten past some of the paradigm shifts that are in there. So for instance, one really basic paradigm shift that comes with the actor model is that everything is always asynchronous.
Right.
So it's those types of lessons that you have to kind of translate from object-oriented programming to the actor model that are kind of the biggest barriers to adopting it, I think. But once you get past that, learning the syntax, learning how to build things with it is pretty straightforward.
You just got to get used to everything's a callback. That's just life. There is no other way.
Yeah. The other areas, so I like I mentioned earlier before the call started, I was doing an on-site training with some customers in Europe this weekend, teaching them how to build some business systems on the backs of Akkad.net. And I see this a lot when I walk into a .NET shop that's been using SQL Server and ASP.NET and IIS for 10 years. Well, another example of this sort of paradigm shift at work is a lot of these developers put consistency on a pedestal as though it's like this sacred religious object that can't ever be violated, right?
And you're talking about synchronous consistency too. Like everybody wait while I get consistent.
Yeah, exactly. It's the sort of, they basically believe the universe should function like a single row in SQL Server.
Right.
Yeah. But then at the same time, the reason why I'm there in that office being paid to teach them how Akkad.net works is because that approach doesn't work at scale anymore, right? So another one of these paradigm shifts is introducing the idea that eventual consistency is actually probably the less expensive and more practical solution for a lot of these problems.
Absolutely.
Helping them work through that and make that real, turning it from just an abstract sentence into a real practical business example is another one of those sort of pieces of intellectual overhead that you have to pay before you can really get maximum mileage out of something like the actor model.
Yeah. Hey, guys, let's hold that thought for just a second while we take a moment for this very important message.
Hi, this is Richard. The Dev Intersection Fall Show this year will be December 3rd to 6th in Las Vegas at the MGM Grand Hotel. The lineup is awesome. Scott Guthrie, Scott Hanselman, Scott Hunter, yes, all the Scotts. But also a ton of great industry speakers for some insight on what's coming up in the world of .NET. Core 3 is bringing client technology like WinForms and WPF into play. Could it be time to migrate your existing desktop apps to this new technology? Come learn more at Dev Intersection, December 3rd to 6th in Las Vegas at the MGM Grand. Go to devintersection.com to register and use the code .NETROCKS to get a discount.
All right, and we're back. It's Carl Franklin, Richard Campbell, and that's Aaron Stannard, and we're talking Akkad.net, actor model, and the reasons one would choose the actor model, an actor model tool like Akkad.net. It makes me wonder if you guys have used SignalR, right?
Oh, yeah. SignalR and Akkad.net go together like peanut butter and chocolate.
Well, this is what I'm bringing up here is that I totally agree. You've been in that situation where, okay, I got some SignalR communication going. Now I have to identify the users, and I have to keep a context around each of the users, and we have to have some state and all of that stuff. But yet you're essentially doing it all in one place, right? Whereas you're getting a general call in the hub, looking up the user, trying to figure out the context, and then you're doing something with that. I think that might be the point at which you say, maybe an actor model system is a better fit for what we're trying to do here.
Yeah, I'd absolutely agree with that. This is a good use case for Akkad.cluster in particular, where the idea behind Akkad.cluster is this is the tool that Akkad.net developers use for building sort of distributed server-side applications. And the idea is that you can have multiple applications written with Akkad.net that have different responsibilities, and they can all work together cooperatively as part of one sort of heterogeneous cluster. You have your web nodes, which all have sort of SignalR hubs on them. And then you might have a set of business nodes that accumulate state for individual users. So these actors on the business nodes are essentially doing stream processing. Each time an event comes in from SignalR, that event gets routed to the exact same actor inside the network every time. So essentially one actor owns 100% of the state for one entity. And the way that's done usually is through something like Akkad.cluster sharding or a consistent hashing router. These are some of the tools for actually figuring out where on the network that actor is. But that state makes it to that node. That actor on that node will receive that event from SignalR, and it'll go ahead and update its local context, and it might produce a reply back. And that actor will just send a reply back to whichever actor originally contacted it. And that actor will be running on the web server where that user is connected to the hub. So essentially, you get like a backplane for SignalR out of the box for free.
Right.
Nice.
As part of using that actor routing and everything else.
How would they work together?
So we have a demo application, actually. It's our web crawler app that we use for teaching Akkad.cluster. And I just recently rewrote it to use SignalR for .NET Core, and I think I Dockerized it. So it uses Docker Compose to spin up a cluster. So I can drop a link to that at the end of the interview. But the way we do that is we have an actor that gets a hub context for SignalR injected into its constructor. And we use one actor on each web server to go and communicate with that particular hub on there. If we needed to do something like, let's say, broadcast a message to 30 users, all on the same hub, but those users have WebSocket connections to different machines. In Akkad.net, there's distributed pub sub, which is sort of a decentralized topic broker. We might have a topic for each chat room, or if that's the example that we're using here. And we would go and publish a response back to that topic. All of the SignalR actors connected to the hub on each machine that has a user running in that chat room would go and receive an event and publish a copy back out.
Yeah.
That's sort of how we could go and facilitate that type of sort of backplane functionality there. It's really basically just through, you have some actors that kind of interface with SignalR. The SignalR hub itself would probably be coded. Whenever it receives a message from JavaScript, it would go and tell a message to its local actor reference. And that actor would go ahead and have another actor that it talks to figure out how to route that message over the network to somebody. So go and break it apart into separate, small, single-purpose actors, essentially.
Well, and this seems to be the strength of the model in general, right? It's like everything is single-purpose, and it's the cascade of them working together that's where you get the complexity rather than actually trying to do everything at once.
That's exactly right. The actor model from a design process is very much a bottom-up experience, where every actor usually has a fairly tightly defined set of responsibilities and scope. And let's suppose you have an actor that owns a domain object that is fairly complicated. So for instance, we had a customer that was using Akkad.net for doing urban planning software, where they could have a project that they managed that was like 5 apartment buildings that took over several city blocks. And there might be thousands of apartments in there. Each one of those big apartment complexes was one domain entity, and they had to be able to keep track of work items for something as small as like changing a light switch cover in one of the rooms, in one of the apartments, in one of the buildings.
Wow.
So what you can do with the actor model there is say, okay, well, even though this actor owns this large object that has a ton of sub-entities and a bunch of sub-facets, in Akkad.net, you can use the actor hierarchy to go ahead and decompose that big object into a bunch of child actors that are extensions and essentially break the state down into its smallest component parts. And you can go and essentially hide all that complexity from anybody else who wants to send a message to that actor that owns that one apartment building in that example. So it's the fact that we basically are able to take really big problems and break them down into very small, easily understandable units of work, and just use essentially very tightly scoped sort of interactions between actors to build these systems that can run lots of different activity in parallel for lots of different entity instances.
So suddenly Phobos comes into clear picture for me, because as soon as you have all these little parts all working simultaneously the way they do, and asynchronously, trying to figure out when things go wrong has got to be a challenge.
Oh, yeah, it definitely is, particularly when you introduce the network into the picture. And so in addition to having, let's say, millions of pieces of work being done simultaneously in a big network, you also have to deal with factors like latency and network partitions and process crashes and all that sort of stuff coming up. So this Phobos tool that we developed at Petabridge allows for developers who are using Akkad.net to use a relatively new DevOps technique called distributed tracing to visualize the flow of activity inside their applications, including activity that happens over the network. So one example, if I'm sending a message between two different actors on different computers inside the network, and let's say at the moment I'm about to send the message from point A to point B, I observe a network failure between those two nodes. What you'd see in Phobos is a message being sent, and then you'd see essentially no acknowledgement, no reply coming back, and you would see the message never made it to the other server in that case.
Right.
We might also record something that's called a dead letter in Akkad.net, which is a way of signifying that this message was undeliverable. And you might see that show up in the tracing system.
And that's a well-known concept in queuing in general, right? The dead letter queue.
Oh, yeah, absolutely. As far back as like early versions of Microsoft Message Queue and things like that, we've always had these sort of concepts of undeliverable or poisoned messages and that sort of thing. I'd say the really big idea behind something like Phobos, though, is really this distributed tracing technology is what's really a game changer there. And that's been becoming a much more popular technique, not just inside actor-based systems, but really even just building HTTP services. We're all increasingly starting to lean on using some sort of inter-process tracing tool. And until really, I'd say about 3 or 4 years ago, we really didn't have a lot of options for doing that. If you weren't, Google or Microsoft, if you're just a normal sort of software developer, you were kind of screwed, to be honest.
Right.
But that's no longer the case. So once again, it's usually one of these internet giants who usually kicks off one of these open source movements, whether it's the NoSQL movement or MapReduce or something. In this case, it was Google once again, published a white paper, I think 4 or 5 years ago, called Dapper, which is their distributed tracing tool that they use within Google's microservices inside all of their products. And from that white paper, it's kicked off a whole bunch of both commercial and open source projects that have gone about trying to make it easier to trace activity inside distributed systems. So, for instance, one of the tools that Phobos integrates with is called Zipkin.
Right.
It was originally a tool built in-house by Twitter for keeping track of the calls between the, I think, hundreds of different services they run as part of running their social media applications. And when your system gets that big, where you have that many microservices and that many people working on it, trying to explain to somebody what actually happened when that user clicked that button on the website is not a trivial problem anymore in a distributed system, because any developer is only going to have a view of the parts of the system they understand, right?
Yeah, right.
And so trying to debug a big microservice application like that has been extremely frustrating for software developers, because the error could occur in some other team's service written in a totally different programming language using a totally different set of tools, and none of that error information is necessarily propagated back all that cleanly. So what these distributed tracing systems really have tried to do is take something that worked really well inside a single process, which is tracing, using something like, you can think of like IntelliTrace and all those tools back from the sort of more recent versions of Visual Studio. And what we've tried to do is, okay, let's develop a tool that allows us to tell a story about how a request was processed from the point of view of multiple processes instead of just a single process. And let's also factor in the idea that these multiple processes might be written in different programming languages by different teams.
Yeah.
Right.
Because what our goal really is we want to take all of that context for how a request was processed, and we want to put it all in one place where all the members of all those teams can go and view it and figure out who should be the one looking into this problem. Like, where did it actually occur inside this system? And so this technology has been kind of getting some major traction in the big internet giant companies, but it's also starting to make its way through early stage tech startups, and even some really big Fortune 500 companies are starting to look at this real heavily. They tend to use solutions that are sort of more proprietary, like Dynatrace or App Dynamics, rather than an open source tool like Zipkin. But there's a lot of companies turning to these tools to try to get some understanding of what's happening inside their system, because they waste a ton of software development time putting engineers together into a conference room to have them all correlate log files from their different services.
Right.
Which is how these problems have been debugged historically.
Hey, Aaron, I'm going to stop you right there for just a minute because, Richard, guess what time it is now?
It must be that happy time again.
Yeah, it's time for an observation. Unlike in Hollywood, the more popular the Akkad.net actor, the more it calls other actors.
I guess that's true.
Yeah.
Yep.
That's right. You never call, you never write.
You never write.
It's actually time to give away a $200 Amazon gift card, compliments of Progress Telerik, to one lucky member of the .NET Rocks fan club. But first, let me tell you about the most comprehensive developer toolkit for building modern apps on the market today, Telerik DevCraft. With more than 1,100 Telerik.NET and Kendo UI JavaScript components and controls, you can easily build modern, high-performant web, mobile, and desktop apps, as well as chatbots. The toolset also includes reporting solutions, automated testing, and productivity tools, and comes with a range of support options. New this year is a free online training program for all license holders. And with this, alongside thousands of demos with source code, comprehensive docs, and a full assortment of Visual Studio templates, you'll be up and running with the Progress Telerik and Kendo UI tools in no time. Download a free 30-day trial at telerik.com/download, and also consider supporting .NET Rocks by making a monthly pledge at patreon.netrocks.com.
All right, buddy. Who's our winner?
Today's winner is Don Zaragoza.
Congratulations, Don.
Congratulations.
Golf clap for you.
And Don just won a $200 Amazon gift card from Progress Telerik just for being a member of the .NET Rocks fan club. And if you'd like to be a member, just go to .NETRocks.com, click on the big Get Free Stuff button, answer a few questions, and join the fan club. We have thousands of members all over the world, and every show we like to give away stuff from our sponsors. And every December, we give away a $5,000 technology shopping spree to one lucky member of the fan club. But you got to sign up if you want a chance to win. And we also like to ask our guests, of course, Aaron, if you had $5,000 to spend on technology right now, what would you buy?
If I had $5,000 to spend on technology right now, if you'd asked me this question a year ago, I would have bought every single possible NVIDIA video card I could sink my teeth into.
For Bitcoin?
Yeah, I would have built a giant cryptocurrency rig.
Yeah.
And cryptocurrency doesn't seem that cool these days.
It's kind of been an in and out sort of market. I was really into it in 2014, and then Mt. Gox happened, and everyone fled like rats from a sinking ship.
So I take it it's no longer hip to mine your own Bitcoin or profitable?
I would say at this rate, mining Bitcoin is probably going to provide you more benefit from the point of view of heating your home than it will in terms of producing actual revenue.
I used to do SETI at home work units. Now it's Ethereum.
Keep that USB coffee warmer going there.
It's going good.
Yeah, exactly. Want to make sure you keep your garage warm at night? Here's an Ethereum mining rig.
There you go.
If I was going to have $5,000 to spend on technology today, I think I would probably spend it on... Honestly, I'd love to go ahead and get my hands on some really good, like 3D sort of like an Oculus rig or something like that. Like a really good 3D gaming setup would be fun. That'd be what I'd spend it on.
And it's interesting you bring that up because it's just in the news. And again, we're at the end of October here. We're publishing the end of November. The guy who started Oculus Rift just left Facebook. And apparently it's over the new Rift hardware that I guess Facebook has decided not to develop it. And so he's taken off. interesting to see where the VR market is per se, because you've got some good hardware out there, but I just don't know. I'm still trying to figure out if it's going the way of HD screens versus 3D screen.
Yeah, I think the biggest problem with the 3D market right now is content is still an unsolved problem.
Mm-hmm.
Because it's just like, well, I can play these really great experiences on my PC or on my Xbox that don't require me to essentially put horse blinders on and trip over coffee tables in my apartment. But they'll come along with something that I think will be a really killer application for it. I'm kind of cynical, so I think that killer application, more likely than not, is probably going to end up being pornography. But
yeah,
that always seems to work.
There was actually a really interesting paper I read in a computer ethics class in college that credibly made the argument that pornography has done more to advance modern technology in the past 130 years than any other field has. And they cited some very specific examples, such as Polaroid cameras, VCRs, JavaScript. And as I was reading through it, I was like, actually, that does make sense.
Better or worse. It's pretty funny, It does have specific challenges on hardware. There's something to be said there for better or worse.
For better or worse.
I did a little history of web development thing. Of course, I show the first web page, and there's no pictures on it because the original HTML spec didn't have image tags yet. That comes later. But the line I always throw up when I throw up that page is, porn comes later, but not much later.
It's always just around the corner, right?
Yeah.
Yeah.
Well, same to be said for VR. If you really want to go down the dark side on that whole thing, it's like, if this was a way to go, I guess that's what we'd be seeing. But it doesn't appear to be the case. But I'm with you. It's fun to build a rig. You certainly need a lot of video card for that too. Definitely.
And it's one of those things where I've been playing video games since I was a kid, and I don't think I'm going to stop. And so I view this as kind of hopefully the next direction those things are going to evolve into, but it's still very early yet.
My friends that are in the video game industry have talked to me about, you can't just port a game over because the 3-foot experience and the VR experience are very different from each other.
I believe that.
Yeah, more than we realize. My buddies, and I'll leave his name out of it because he's telling me secrets he probably shouldn't tell me. He's like, we forget that in a game like Battlefield 1, you're running at about 30 miles an hour.
Yeah.
Because people get bored if they run at normal human speeds, right? Playing the game. They want to move faster than that. And when you do that strapped to your face in 3D, it's not good.
I believe that too. There was an experiment someone did with World of Warcraft about 10 years ago. I think I was in college when they did this, where someone essentially rigged it so they would use an actual treadmill to power the forward and backward movement of their character, just the velocity, not the direction. They could still steer with the mouse. So these guys tried crossing one of the zones. I think it was the Northern Kingdoms or whatever. They tried crossing the zones doing this, and it took them 3 hours to go ahead and make it across one zone, going human speeds here. And they're like, yeah, there's no way we could really play this game, doing that. So,
yeah, the way that video games distort reality is subtle. And when you change the medium like you do with VR, those distortions become very consequential. And I think it's one of the reasons we're having problems with content is as soon as you get into the finance of contemporary video games where it's millions and millions of dollars, there may not just be enough headsets to justify building a game that really takes advantage of it.
Yeah, they'll have to find some cheap source of content that is basically able to be where it'd be a commercial success if only the, let's say 25,000 early adopters go and buy it, right?
Yeah. Well, you want that hero game, that thing that's like, oh, dude, you got to play this, and you can only play it on X. And that's the driver for buying the device.
Yep. Wasn't that what Microsoft was trying to do when it acquired Mojang? Was trying to kind of move it in that direction?
Yeah.
Move Minecraft in that direction, I mean.
You would think so, but Minecraft never went anywhere. But, you think of Halo. Halo was an Xbox seller. That's what it was about, right? And they controlled Bungie for exactly that reason. And it became the definitive game on there. And PlayStation, Sony's always done that. And certainly Nintendo's always done that.
Oh, yeah. Mario 64. That was curtains for a lot of us.
Yeah. You had to have that device if you wanted that game. And that's all there was to it.
Yeah, makes sense.
Well, this is not far off base because there's an awful lot of actor stuff done from the gaming perspective, especially massive multiplayer.
Yeah, there definitely is. A lot of the technology that people use actors for in the game space is basic concurrency problems introduced by just having multiple people in the same area of a game at the same time.
Who do need to interact with each other in some form.
Yeah, exactly. So you have to have little messages that indicate what a player said or what they moved or if they fired a weapon or something like that.
Right.
These are all little pieces of information that need to be broadcast back to their peers.
I just don't think of many business models that have the equivalent where you have these entities interacting that way.
A lot of it is like complex event processing is, I'd say, probably the sort of categorical business case for this. And it's just that that complex event processing is very domain specific. So I'll give you an example from one of our financial customers, which would be like real-time fraud detection on loans and insurance premiums. So I had a CTO of a company that does this in the EU, where he mentioned that for every single person who applies for a commercial bank loan, this could be anything as small as like an auto loan would apply for this.
Right.
They have to make 400 external network calls with that person's data to validate they are who they are. So this involves doing things like hitting the Interpol database. There's a couple of third-party services they subscribe to basically check to see if this email was stolen or not. Being able to go ahead and run credit checks, background checks, all this stuff. We have to be able to go ahead and guarantee that all that work completes in a certain bounded window of time. Otherwise, the customer might bail and go to another bank. And that's a real business problem for us. So what they'll use the actors for there is they'll usually use like a process manager or saga pattern, where you have one actor that's kind of owns the unit of work and goes, I know that these 400 checks all must be completed. And it'll go and push that work out to the rest of the network and gather the responses back in as that's all happening sort of asynchronously in other parts of their system. That's one example. Other examples include real-time streaming problems. This is like what our IoT customers are doing usually, where I have an array of devices out in the field. So since I live in Houston, Texas, I'll give you an example from the dominant industry here, which is energy. I might have an oil pipeline or an oil field that has a very large array of pressure, temperature, and volume sensors that are all built into it, where I'm trying to measure the output of our oil wells or our pipeline, whatever the case may be. And what I'm looking for as I'm processing this real-time stream is I'm trying to go ahead and predict, what's our total output at the end of the day. So it's going to have a real impact on our bottom line and our financials, and also impacts all the markets for how trading is done around that. But I'm also looking at operational metrics that might tell me if we have a safety issue that's occurring.
Right.
Or if there's a maintenance issue going on, that type of thing. Well, in those cases, you have one raw stream of data that's coming in, which is the actual metrics on the devices. But there need to be a bunch of other business actors that are listening to those events and are trying to make decisions quickly that affect totally different business units, whether it's operations or finance or sales, that sort of thing. So those actors are all kind of working together in parallel using the same incoming data set to essentially handle all those different independent business concerns, all drawn from the same information, really. So those are some examples of where that type of event sourcing takes place. It's just quite not as easy to imagine because unless you've been in that field and kind of understand some of the intrinsics of how an oil operation is structured or something like that, it's just not quite as intuitive as a video game where we, as developers and as video game connoisseurs, there's probably, if you drew a Venn diagram there, I'd say there's probably, you could probably fit the entire programmer circle inside the video game one. But we can all sort of intuitively appreciate, okay, well, you might need to have actors to drive NPC behavior and then other actors that propagate notifications in the chat system in this video game, and then some game lobby actors designed to help match players together for a new session, that sort of thing.
Yeah, that makes total sense, and it is interesting to map those ideas across these different application spaces. They're all very similar problems.
Have you seen anybody using an actor system with your standard kind of distributed business microservice line of business application?
Oh, yeah, all the time. We've had people do things like use the actor model inside ERP and fulfillment systems. Those sorts of things. And in that case, the reason why they're doing that is the actor system actually helped eliminate a ton of infrastructure that these companies would have needed to have had otherwise. So, for instance, when you're building a traditional HTTP microservices application, all of a sudden you need access to, let's say, software load balancers for routing traffic within one microservice. You need a service discovery platform for getting access to the API endpoints. So that would be like console or something like that. You also might need an API gateway service for being able to, essentially connect different services together and so forth. And there's lots of different little pieces of infrastructure that all kind of need to be bolted on together there and shipped with your microservices. Inside the actor model, something like Akkad cluster, which is the little tool we use for connecting all these services together, service discovery and routing and load balancing are already built into how those tools work. That's essentially the routing system in Akkad.net is the primary instrument for accomplishing a lot of that. So it's basically a way of kind of flattening, from an infrastructure perspective, a lot of those concerns. The other reason why they would be interested in looking at using actors to build those traditional line of business applications is the ability to introduce real-time behaviors to systems that didn't really have them before. Good examples of that. So we have a lot of customers in manufacturing that use Akkad.net, and they're mostly using it for managing essentially production flows on the shop floor. Well, if I notice that there's been some issues with production in one area of the shop floor, I can go ahead and dispatch, notifications really, in real time to have someone go and take a look at it as the problem's happening, rather than dealing with it the following day once the batch system catches up with it, which is what people would traditionally do with stateless microservices. Is all that state would still be resident inside a database, and you wouldn't know about a problem until you went ahead and analyzed everything in batch later on during the day. So from a business and process improvement standpoint, leveraging real-time components like actors gives you the ability to make real-time process improvements as well. So there's some definite advantages to doing that.
Nice.
Yeah, that's something that you wouldn't expect. And it makes a lot of sense just because all the core infrastructure is there. And I just wonder, how flexible it is. I mean, one of the benefits of microservices is that you have everything so isolated that you can scale the individual services up and down according to, how much they're relied upon. And do these things just magically happen behind the scenes in Akkad.net?
Let's say I replaced a distributed microservices application that's built on top of HTTP and REST. Let's say I went ahead and replaced that wholesale with Akkad.net. You would lose some of the flexibility you had before, for sure. That's one of the trade-offs there that you'd have to make. In particular, you would have to manage your message formats, basically the sort of way messages are represented on the network between services. Managing that would require a much greater level of thought than just HTTP output responses does. Because essentially everything is, you kind of move from being able to dynamically type and fuzz things a little bit with HTTP.
Yeah.
To needing to have these sort of statically typed message formats on the network. So there's some cost in doing that. And it's mostly a human cost. It's an organizational and a communication problem, not really a technical cost, if that makes sense.
Yeah, sure does. So
there's that. There's the fact that you can't really, you lose that flexibility in being able to choose different runtimes for building applications. So if you have people who are building some services in JavaScript and some in Scala and some in .NET, well, if you wanted to go ahead and have everything run in a unified single cluster, you'd have to have them all standardized on something. Now, that being said, I think what I would probably recommend as a CTO when I'm working with a customer is I would probably only really use Akkad cluster in environments where I needed that real-time state processing. And I wouldn't necessarily introduce it everywhere, just sort of, because we should just only use one tool, right? I probably wouldn't do it that way. I'd probably have some areas that have other microservices that maybe my cluster would call. And it might call those microservices using HTTP, or maybe we'd use a message broker like RabbitMQ or something to go and communicate with those other external systems that are implemented using maybe different programming languages, or maybe they're running legacy code that isn't going to translate very well. Not translate very well, but not translate very quickly into actor designs. So realistically, most major adopters of Akkad.net don't have the option of moving everything onto actors. It's just not a feasible request from a business standpoint.
So, I mean, you talk about a typical microservices architecture, and you mentioned RabbitMQ, but queuing solutions and so forth. Where would someone decide to apply an actor model? Like, what improvement is it going to make if it's not in everything?
The biggest improvement using something like the actor model would make is if you needed to process responses quickly that were, let's say you had some requests that you sent over RabbitMQ, and we're talking about the subscriber side of RabbitMQ rather than the publisher side now.
Mm-hmm. Right.
If the subscriber side needs to be able to turn around some output in a very short window of time, let's say for argument's sake, every request must be responded to within, we could say 100 seconds, but maybe the window might be as small as 40 milliseconds, something like that. Well, if you're dealing with those types of business requirements, round-tripping data into the database and doing this sort of read after write semantics, where every new record you process requires you to write it into a row in SQL Server, and then you have to go ahead and run some sort of select query and produce an aggregate and send that response back. That approach simply doesn't scale very well. And what you could fix by moving to the actor model would be able to move all that processing from something that occurs inside a centralized database into memory in a decentralized cluster where you can just throw more hardware at it if you want. So that's one of the biggest areas where bringing in the actor model can help, is it allows you to move your processing into a higher level of I/O and start taking advantage of being able to use state locality, essentially, where all of the information you need to do your work is adjacent in memory to the code that does it. So there's a very big, like 2 or 3 order of magnitude improvement and processing time you can achieve by doing that.
Very cool. So what's next for Akkad.net that we haven't talked about?
No, we haven't talked about it yet. What's next for Akkad.net? We have a big release that we've been working on called Akkad.net 1.4. And what's going into this release is some improvements to Akkad.cluster and Akkad.streams. In Akkad.cluster, we're going to be adding support for multiple data centers, since that's increasingly becoming a requirement that our customers care about. So they want to have the ability to go and distinguish physically which nodes in a cluster are all resident together in the same data center and which ones aren't. And that might change your strategy from like a disaster recovery or a latency optimization standpoint of how you communicate with different nodes in the network. So that's one of the big features. Akka Streams, which we haven't talked much about, which is kind of a higher level abstraction on top of Akka.net that allows you to build sort of real-time publish consume type systems that are back pressure capable. So they're really good at essentially balancing themselves. And it's very fast, very high performance. Works with a lot of off-the-shelf third-party technologies like Kafka and Rabbit and Azure Service Bus and SignalR, that sort of thing. One of the limitations with Akka Streams today in Akka.net 1.3 is that all of your streams, when we compile it, we can actually compile a stream into actors. Akka.streams syntax looks like LINQ. They all look like little LINQ expressions, all the different stages in a stream.
Fluency.
Yeah.
The fluent syntax.
It's very expressive and very powerful, but one of the limitations is that stream has to get executed by actors that all run in the same process today. That will no longer be true starting in Akkad.net 1.4. We're going to have the ability to partition streams across a cluster if we need to.
Wow.
So that'll be a big feature. We're also working on adding some better support for .NET Core 2.1 in a number of areas. I don't know if we're going to dig into taking advantage of spans and memory and some of those other new zero allocation sort of memory structures. I don't know if we're going to be able to take advantage of that in Akkad.net 1.4 because some of the libraries we depend on for things like serialization and networking may not be using those yet. So we're going to look at it and see if we can achieve some performance improvements there, particularly around our networking systems. That's always sort of the biggest area that we're looking at. And then some of the other work we're going to be doing around Akkad.net itself is going to involve improving the performance of Akkad.persistence. We're looking at doing a pretty big restructuring of that at the moment. And we're also going to be trying to get Akkad.distributed data out of beta. Distributed data is our library for doing eventually consistent replication inside Akkad.cluster. So I can have 3 or 4 multiple writable replicas of an entity. And all those entities are able to synchronize together using a special data structures called CRDTs, conflict-free replicated data types. That technology's been in kind of a beta state for about a year, and we're going to move it out of beta as part of 1.4. I'm not sure on the exact release time frame. That kind of depends on, there's a couple of external factors that are going to influence that, but it's actively being developed right now.
Yeah.
And I hope it would be out by early next year.
Very cool. Well, geez, this sounds awesome. And we encourage everybody to go check it out at getakkad.net.
Yep, getakkad.net. And thank you, gentlemen, for having me on. It's been a pleasure talking to you. And I hope your listeners end up giving Akkad.net a try. You can learn more about it at learnakkad.net. That's where we have access to our sort of Akkad.net bootcamp up there. And I think we've had something like 40,000 people learn Akkad.net going through there.
Nice.
So definitely recommend taking a look at that if you're curious.
Well, thank you again, Aaron. It's been great. And we'll talk to you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got a transmitter banned by the FCC. Yes, I'm a